There is a need for rapid and portable molecular detection methods and devices. F-Cubed has addressed this problem by licensing technology from the University of Notre Dame to address issues in the environmental, defense, and medical diagnostics fields. F-Cubed has completed the development of their first device for use with environmental diagnostics, and it is ready for immediate purchase. Les Ivy is F-Cube's CEO.
We developed our products with the intention of moving environmental and medical diagnostics out of the laboratory and away from laboratory technicians, moving them directly into the hands of physicians and people who use them for environmental diagnostics. There are a variety of test methods available to protect the public from environmental pathogens such as Enterococcus and E. coli. The problem with those test methods is that they consume quite a bit of time. They take between 24 and 48 hours before a result is provided. Our objective is to provide those same results within 10 to 15 minutes, enhancing public safety. Rapid tests are very important, but it's just as important to be able to do tests on site in a physician's office or on a beach where there are environmental hazards present. It is also crucial to be able to do tests with lay people, that is, people with limited training who can handle the equipment and do the work on a daily basis. I've been involved in analytical instrumentation for almost 2 decades, and I have been looking for something to solve the problem of molecular diagnostics or rapid molecular diagnostics. That's why when I came across this technology at the University of Notre Dame, I was so excited.
Dr. Chia Cheng is the inventor of this technology. It's very rapid, highly specific, and very simple. Other existing diagnostic devices can only be used in the laboratory.
We built the technology because we want to have the first diagnostic device that can be used out in the field. And this new platform that we have constructed essentially allows us to use it out in the field with untrained personnel. Quite often with environmental and also medical diagnostic devices, the challenge is to be able to carry them around out in the field and to actually use them without much clinical training or experience. And this is exactly what the device is meant to be. So the heart of this device is this biochip. And we have fabricated microelectrodes onto the chip to impart a DEP force on the molecules. And by doing that, we can reduce the asset time from 30 minutes or hours to 10 minutes or less. So it makes it very, very rapid and hence suitable for field applications. DEP is a dipole force that an AC electric field can impart on a molecule. It's difficult to attract molecules to the sensors, to the electrodes, except with this kind of dielectrophoretic technique. And that is, if one can use an electric field to form a dipole on the molecule, then the molecule now would then feel the presence of the electric field and then go to the high field region on the electrode. With E. coli, what we are really interested in is to identify the particular E. coli strain that we have in the sample and also to quantify the number of E. coli. So this platform with the DEP technology allows us to do that. We can genetically identify the particular strain, and we can also count the number of E. coli in the sample, and all very rapidly and also with a very small device like what you see here. Portability means that you need to have something that a person can carry, and that right away rules out just about all fluorescence detection technologies that are out there. With this biochip, all you would need would be a small electronic equipment that can be used to measure the impedance across the electrode. And all the samples could be introduced into the reservoirs that you see over here, and then the sample will be pumped through the biochip, all with very, very small devices that you see here in this briefcase. What is also most interesting about this device is we can now do RNA detection. Each bacteria would have tens of thousands of RNAs, but only one copy of DNA. So if we can do RNA detection, that will eliminate the PCR amplification step entirely, which makes the detection even more rapid. So fortunately, because our assay time is within 15 minutes, which is shorter than the lifetime of the RNA, so we can do RNA detection, which is not possible with the current technologies. So we have tested the platform with E. coli detection, with TB bacteria detection, with also various kinds of other bacteria and viruses. So it's a rather generic platform, and what we see in the future is a multi-target detection unit. So we do not just detect one specific pathogen, but maybe a large number of them all with the same device. Biochips are made with glass, and we have etched microchannels into the chip so that you can pump the sample continuously through the chip. The electrodes, which are the sensors, and also the electrodes are the units that actually impart the DEP force on the molecules. These electrodes are fabricated on both sides of the chip, and they are then bonded together. So it's a new way of making biochips and doing diagnostics. We're fortunate to be able to work with a company to integrate all these scientific knowledges into something tangible, something that is going to make an impact out in the field, both commercially and also in terms of contribution to medicine. The key features are, again, that we can make these devices very economically. We can get much faster assay time, and we can take the devices out into the field. And also in terms of RNA detection, these devices are actually the first ones that can be able to do RNA detection out in the field. Medical and environmental diagnostics out in the field demanded a totally new platform, and we're very excited that we can come up with this new device.
The technology we've developed makes rapid and portable molecular diagnostics possible for medical and environmental applications, and it's available now.
F-Cube's technology is simple and powerful and can be used for environmental, medical, and other applications. For more information, contact us at info@fcubed.biz or at 574-217-4974.